Everyone, and welcome to my online teaching platform. We have our third question on application of differentiation in relation to normal and tangent to a given curve. All right. So we have our third question here to be. Let us start with the three a. Given that xy is equal to 1, find dy dx at the point with coordinate +1 and +1. All right. So we are to find the gradient of the given curve at the point with coordinate of x being 1 and coordinate of y being also 1. Alright, so let us start work. So our solution, okay, so we have the function to be xy equal to 1. This is an implicit function. Okay, now you can see that at the left hand side of the equation we have x multiplying y. So we can apply the product rule where you differentiate your u and you multiply it by v, then plus you maintain your u and multiply it by the derivative of v, which is v prime, equal to 1. All right, so this is what we are going to do. So you can name your u to be x and your v to be y. Okay, so we are going to apply the product rule at the left hand side of the equation where we have the x, y. So let us differentiate our du. The x will be 1. Okay, so when you differentiate function u with respect to x, we are going to get the result to be 1. Multiplying our v is y, plus u also multiplying the value of u is x, multiplying the derivative of v. So when you differentiate your y, you are going to get 1. Then the result multiplied by dy dx. I think I have explained it in the first video under how to differentiate implicit function. How to differentiate implicit function. So the first video under implicit function, I have explained why anytime you differentiate the dependent variable, you must multiply it by dy dx, all right, or which is the same as the y prime. And when you differentiate the right hand side, when you differentiate 1, you are going to get the result to be 0. Okay, so 1 times y will give us y. Then here we have x times 1. We are going to get x, then dy dx. Okay, all equal to 0. So we need to make dy dx the subject. So we are going to get x dy dx. Then we transpose the y here to the left hand side, becoming negative y. We are looking for dy dx, not x dy dx. So we divide through by x. Okay, so we are going to get, or you can multiply through by 1 divided by x. So we can write 1 divided by x times x dy dx. Then here to negative y also multiplying 1 divided by x. So this x, you can say this. So we are left with dy dx being equal to negative y divided by x. Alright. So this is our dy dx. And we have to find dy dx at the point with coordinate 1, 1. Alright. So it means the second one will be for y and the first one is for x. Okay. So we just need to plug in the values of x and y into the gradient function and you'll be able to get your gradient. So wherever you see y, you put the value of y over there. Y is negative, sorry, y is 1. So, but there is negative over there, so put our 1 in place of the y. then divided by x, x is also 1. Okay, so we are going to get a result to be -1 divided by -1. Sorry, -1 divided by 1, and that will give us a result to be -1. All right, so this is the gradient dy dx at the point with coordinates 1, 1. All right, so this is our result for 3a, the solution for question 3a. All right, let us look at 3b. Okay, 3b says that a function f of x is given to be x cubed minus 3x squared plus 4x plus 1. You have to find the derivative of the function f of x with respect to x. Okay, so that is the I part. So I part says that we should find the derivative of the function f of x with respect to x. So this is what we are going to do. Only find df dx. So meaning you are differentiating the function f with respect to x. So we just differentiate to get 3x squared, then minus 6x here plus 4. All right. Okay, so we are done with the I part, and the I is saying that we should find the gradient of the same function at the point A. So gradient of the same function, so gradient of f of x at point A. The point A has coordinate 2 and what? 5. Since you are to find a gradient, you only get your gradient function, which is df dx, but we have already worked for the gradient function in I. So we just pick our gradient function, our df dx, which is the same as the gradient, which is m is equal to 3x squared minus 6x plus 4. Okay, so this is our gradient function, and we have to find a gradient, not the gradient function. So we are going to get it as 3. We are going to substitute the x component of the given point because we are finding the gradient at that particular point. So it means at that point x is equal to 2. So wherever you see x, you put 2 in place of the x. Minus 6 also multiplying 2 plus 4. And here will give us 3 multiplying 2 squared. 2 squared will give us 4 times 3 will give us 12. Minus 6 times 2 will give us negative 12. So negative 6 times positive 2 will give us negative 12. All right. Plus 4. And you get a result to be negative 12 minus 12 will give us 0 plus 4 will give us 4. Okay. So this becomes our gradient. So the gradient of the function f of s is 4 at the point A. So at A, okay, this is the gradient of the function at point A. All right. Now we are to also work on the I part of question 3b. The question 3b I says that we should find the equation of the tangent to the curve at. So equation of the tangent to the curve at point A, which is 2, 5. All right. That's what you have to find out, which is the I part of question 3b. So how do you find equation of a straight line? A tangent is always a straight line that touches a curve at only one point. Okay, touches the curve once. So you use the equation for finding, sorry, the formula for finding equation of a straight line for that of a tangent. We know the formula to be y minus y1 equal to m, which is the gradient, multiplying x minus x1. All right. And we know x1 and y1 to be the x and the y coordinate of the point on the tangent. All right. You only need a gradient and a point on any straight line to find the equation of the line. So since point A is also on the tangent, that's where the tangent touches the curve. So we say that that point is also on the tangent. And now that we know that wherever the tangent touches the curve, the gradients are the same, we are going to use the gradient of the curve at that point for the gradient of the tangent, because that's the point where the tangent touches the curve. Right? So from what we learned in our first video, our gradient will be equal to the gradient of the curve, and we had a gradient to be positive 4. Okay, so we had a gradient to be positive 4. Then let us get our A. So our A is also here. We are going to use the same point. So this is our x1 and this is our y1. All right. So our equation will be y minus y1, which is y minus 5, equal to the gradient of the curve, which is the same as the gradient of the tangent, because they meet at A. And that's where the gradient of the curve is 4. So the gradient of the curve at that point is the same as the gradient of the tangent. So 4 multiply x minus x1, and the x1 is positive 2. So we are going to get y minus 5 equal to 4 times x will give us 4x. 4 times negative 2 will give us negative 8. All right. So here we'll be getting 4 minus 5. Sorry, y minus 5, sorry, equal to 4. So let us transpose it. Yes, anyway, so we can transpose the 4x to the left hand side. So y minus 4x, then we have negative 5 at the left hand side. Then we transpose the negative 8 at the right hand side to the left hand side. So we are going to get it to be plus 8, all equal to 0. This will give us y minus 4x, then negative 5 plus 8 gives us positive 3. Right, so this becomes the equation of the tangent to the curve given. Okay, all right. So anytime you have a curve and you have to find the gradient of the curve at a given point, you differentiate the curve to get the gradient function. Then you substitute the x and the y coordinate into the gradient function. So if there's no y component in the gradient function, you only substitute the x component, and that will give you the gradient of the curve at that particular point. Now, if the tangent touches the curve at that point, then it means that point is also on the tangent. And you should know how to find the equation of any straight line of a tangent. You only need a gradient and one of the points on that particular line. All right. Now we have the point A to be on the curve and the tangent because that's where they meet. So that point is also on the tangent. And we know the tangent to be having the same gradient with that of the curve at where they meet. Okay. So the gradient of the curve we had it to be 4. So you just use the same gradient. Then you pick the coordinate of the point where the tangent touches the curve to be a point, one of the points on the tangent as well. So you pick the x component to be your x1, y component to be your y1. Then you plug those values into the equation of a straight line formula. So the formula for finding equation of a straight line, y minus y1 equal to the gradient multiply x minus x1. All right. Thank you so much. Please do not forget to subscribe to my YouTube channel, and you can also share with others to watch my videos and also like my videos. Thank you. Bye.